Hello, everyone. Today we're going to talk to you about Hashcraft, a prototype that we've been developing in the Strategic Innovation Lab, which is a lab within Ubisoft. We're going to tell you more about this. And this is to give you an idea about how we do open innovation and innovation within Ubisoft. And it's related to blockchain because this is a prototype about blockchain and procedural technology for content creation. So, first of all, who we are. I am Robert Falce, Pierre Armand Nicq, and we are part of a Strategic Innovation Lab. So the Strategic Innovation Lab and the makers, we are a team of 15 people. We are focused on prospective research, which means we do research not only about technology, but also about sociological aspects of how technology is going to affect us as people. And we monitor the trends, so tech or not, and find the weak signals. By weak signals, we mean things that are barely visible right now, but that are going to become trends, big trends in the future. So this is the idea. And our role is internally to evangelize technology and so sociological aspect for our teams to take it into account when they are making their own games. So the Strategic Innovation Lab is 15 people, 7 of them are about researching, and then within this team we have 4 people, the makers, who are the team which are going from the prospective research, which is usually a compilation of information, PowerPoints or other presentations like this, and we make it tangible into a prototype, whether it could be a video, it could be a website, or it could be, in our case now, a full-fledged prototype of a 3D video game. So in the team, we have Nathalie Paccard, which is the producer in the team. We have Camille Richard, which is our game designer. Me, I'm the lead developer on the project, and then we have Pierre Armand, which is technical artist and developer. It's a good thing to know that the 3 of us, which are actually doing the prototype, because Nathalie is producing, so she's taking care of larger idea of the thing. The 3 of us are actually programming because we are a very small team, as you can see, so we need everybody to be able to move forward with the project. And we also had some initial design from Jan Sarah, who is a game designer at Ubisoft as well, but he's on another project right now. So, about the game itself, we invite you to see it on the Ubisoft booth upstairs. So if you want to come, play, and ask for some more questions later, you can always come to us, and we'll be really happy to have a talk about the prototype with you, and you can share your ideas and your vision on what game with blockchain could be. So, in our case here, game design and the blockchain, what we have is we try to see how we could use the blockchain in a way that is not focused on transactions, marketplace, or ICOs, because we know Ubisoft, or we have partners who knows how to do that. So to us, it was not really as part of a strategic innovation lab. It was not really interesting to go this direction. We wanted to be able to inspire the teams to go in other directions. So what we did was, okay, what's the fundamental, the core of the blockchain technology for us? And how can we inspire teams to go beyond what I just told you now and see if we can maybe try to deeply integrate the blockchain within the game. So the idea was, okay, the blockchain is really, there's this immutable, really resilient and really, how could I say, with you cannot modify, you cannot delete, well, immutable. With these 2 cores and ever-expanding, that's what I wanted to say, ever-expanding as well. These 3 principles were the ones that are focused, that we really liked. And by this we mean Ubisoft, we are really good at creating universes for our game. Before, when you create a game, we really think about the universe within the game, within which the game is going to take place. And so here we thought, okay, we have the blockchain on one side, we have the universe on the other side. How can we conciliate these 2 things and see the connections between them? And we thought, if a blockchain is some thing that's growing, ever expanding, and if we would like to be able to expand our games, you know, to have more and more content. Maybe there's a parallel to be done between the blockchain and the universe in that sense. And so we started to think, okay, the blockchain could be a universe in a game. And then what we could see as block or transactions could be some content that the user is going to add on top of it. So this is what we try to do. And this is, again, something that we try to do in a way to raise awareness in the teams and studios within Ubisoft, because sometimes the teams, more than a PowerPoint, having an actual 3D interactive content is going to help them project themselves into an actual game, because sometimes it's much better like this to help sell an idea. So this was really the core for us, trying to find out how to attract the teams towards this new technology, which is not clearly, it's not clear for us as game developers at first when we start, how it's going to relate to a game. So here, you know about blockchain, so I'm going to go quickly with this. It's trustless, it's decentralized, it's append-only, immutable, persistent. You know all about this already, so I'm not going to go forward with this. The common uses, again, that's what I've described before. You have the financial transactions, you have cryptocurrencies, you know that's distributed ledgers and the ICO. So these are all things that we identified really quickly. And we thought, okay, if we want to reach the people we want to reach inside Ubisoft, we have to go beyond that, or at least on the side of that. And so, as I said, we did the parallel between the blockchain and the in-game universe, tried to correlate them as much as we could. And so, it was a way for us to help the player become a stakeholder in the universe of the game. How? It's because instead of us creating the content from scratch at first when we have the game, we did something where the player, you could make a parallel. It's not a proof of work, but it's something similar to a proof of work where instead of just generating a check for the hash to validate a block, what we do with the proof of work would be similar to creating an island for our game. So it's not the same thing as a proof of work per se, but it's similar in terms of what we want to do with it, which is validate, create some value out of the calculations that are going to be done by the user. So the user is going to use his computer to create an island, and then once it's validated by other players, something like a distributed proof of stake, for example, then once it's validated by other players, we can put it on the blockchain and reward maybe the player with tokens. So this is hypothetical. This is just the idea that we had when we started the game, the prototype. And this is what we started as the base for the prototype and try to convince people within Ubisoft. So basically the game is an exploration game. You go from island to island. Either you go on somebody else's island or you create your own. And by creating your own, you lend your computer, your time, your energy to create some islands. And then once it's published on the blockchain, you can claim the ownership of the island. And you can be rewarded with tokens that you can use in the game, or possibly we could think of maybe using it in a larger ecosystem of games, if it's possible. It's all depending on all the actors that want to play along with this. So, when we designed our game, first thing to know is that we are game developers. We are not blockchain experts. So we took it quite naively when we started. And so the main considerations for us were in terms of immutability, because it's really not ideal for us as developers doing a game. We are used to be able now to patch games. So when it's out, you detect some problems and you fix it later. This is not necessarily something that's easy to do with a blockchain, depending on what you put on the blockchain as data, because we wanted to put data on the blockchain, not just transactions. So here we really had to think hard when we started what's going to be on the blockchain and how it's going to affect our ability to update the game later. So this was something that we really had to take into account. The other problem we had as well for us was the concurrency, because you all know that a blockchain transaction can take a while to be validated by the network, depending on the size of the network and the technology you're using. Which means that maybe some people can try and create the same island, for example, and try to publish it together. And when this happens, well, it might be that somebody thinks he's created the island, but somebody beat him to actually doing it, and then after that you have this concurrency. Who do we reward? Do we reward one of them, two of them, none of them? It's all these things that when we started the game, it was not clear that this problem existed, and we had to take them into account as we went along. And finally, we have this latency problem that is very complicated for us to deal with, because we like to be able to give feedback as soon as possible to the user. The point is here, when you are a user and you do an action, you need to know quickly if it's positive or negative, and on this feedback you can build your experience on the game and you can develop yourself. If the longer the time between an action and the feedback from this action, the harder it is for the user to understand the connection between these two things. And as you know, blockchain, if you do something, like in our case, you publish the island, and it can take a while to do so, you have to take this into account. So you have to find a way for the user to know that these two things are connected. And it was something that for us was quite complicated to go around. Also, quickly to point out, we did our best to only use blockchain as a network and database capabilities. So we don't have any side database. We don't have any other ways of communicating between the players but the blockchain. We did that on purpose to put as many constraints as we could and try to squeeze as much information as we could from the blockchain, from our learnings from the blockchain. Because if we started to rely on multiplayer, for example, or we started to rely on database, we would never have learned as much. So if you have time to prototype, it's a good thing for us, I think, to try and not take any other technology and squeeze as much as you can from the blockchain. And then after that, you can add some more stuff if you want. So, again, probably as you are quite familiar with blockchain, the things to avoid to put on the blockchain for us as game developers, it was quite a new experience because we are used to database. It's not a good idea to put some stuff that needs to be updated, like a counter, for example. For us, it's very obvious to say, oh, we have one player that's being added on the island, so all we have to do is just increment a counter. On the blockchain, if you do that and if you store the information, you're going to just spam the blockchain with some not so interesting information. So instead, if we have to do something like this, we need to make it so that it's got a history in the game that is worth revisiting later for the player. Otherwise, it's wasted resources. So for us as game developers, it's something that we are not used to. And as well, it's you have to be careful about the size of your data set, especially that for us, again, as a constraint that we imposed to ourselves to learn as much as we could, we tried to have every player to be a miner in the game. So by being a miner in the game, you have the blockchain, and so you have to deal with the size of the blockchain. So we had to deal with having billions of islands in our game, and in the meantime, being able to store all this information on the player's computer. So what we did was trying to have a two-pass island generation. So the first pass is a complex part. So this is, again, something that is not entirely visible in the prototype upstairs, because to make it faster for you to reach an island, the time to create the island is much shorter than the time that we would like it to be if we actually did a product, for example. But the idea is the first pass should be long. It should make sure that the island that's created is very interesting for the player, because we test against some rules in game design and level design. And so if we have some objects or artifacts that we want the player to reach, we need to make sure that it's actually possible to reach it, and that it's possible in a way that is fun as well. So for that, we have to follow more rules than just generating some 2D terrain, for example. We need to make sure that going from point A to point B, you're going to pass through certain events that are going to make it more interesting. So in that case, we think a good idea would be to try and create an island within 5 to 10 minutes to replicate something similar to what you could do in a proof of work today. And as well, to make sure that you have enough time to create some content that is going to be more interesting than just generating real-time content on the fly. We can do that, but it's not as interesting for the player. After a few times, it gets quite repetitive. So we have the first pass, long, and it has to generate a really small file. Why? Because this file is the one that's going to be stored on the blockchain. And if we want 2 billion islands on the blockchain, you have to make sure that this file is so small that 2 billion of those files are not going to destroy our computer's hard disk. So here, we set the limit for ourselves at about 10 kilobytes. Then from this file, everybody that's creating an island is going to add its island on the blockchain. From this file, then you should be able to load an island within 20 to 30 seconds, as a normal game loading should be. And this part is stored on the computer on the fly when you play, but it's never stored back on the blockchain or anything. It's just every time it's been redone. But the main part is really the first part. That's where the hard work is done, and that's where the player is going to be rewarded. So in our case, again, one of the constraints we had was to try and not being a side chain of a network that existed. We tried as well to do something that we could use internally, because at first this project was not supposed to be released publicly like it is now, shown publicly, not released, it's not going to be released, shown publicly as it is now. So we thought, okay, we have to deal with some technology that we can embed in the game, and where everybody can be a miner, and when we can control the outcome. So we thought multi-chain at that point for us was a really good fit. Private blockchain for us was interesting if we needed to use some permissions. It was really easy to integrate as well. It's lightweight in the sense that there are many ways to do a miner on a computer, but usually it's quite large in terms of space, where here we could use just an executable about 30 megs. We just link it inside the game, and then that's sorted. For us, there was no proof of work, which meant we could add one if we wanted to, but we didn't have the time. Or we could just go straight to the point, and so we can rush the presentations because people are not going to wait for a proof of work. And it handles both transactions and streams were useful for us as well because it was fairly convenient to be able to access an island using an ID, because this way you can access it quite faster than having to go through all the blocks. It was cross-platform, although we didn't have to use that. And as well, the community and the support was quite reactive, so it was a great help as well. So again, multi-chain, on the other hand, is not necessarily something that's going to play along with Unity, which is our game engine. It's not going to play along very well from scratch. You have to develop some wrapper around a library that exists, that's LucidOcean. So this library allows us to do RPC calls to multi-chain executable. And then we have our own wrapper around this LucidOcean C# wrapper that is going to allow us to link it with the Unity lifecycle. So basically, that's how we integrated multi-chain with Unity. It was not always easy because, again, we are quite new to this. And yeah, as I said just before, multi-chain, the way to store the information for us, really easy to access through an index-based stream. So that was really useful. And again, there was one problem with this for us, that the streams, there was one condition that we are not sure why it exists, but that's how it is. We first had to have a transaction before we were allowed to contribute to a stream. So we had to create a whole other executable that had to run alongside a node that we hosted ourselves for the first player connection to be awarded a fake transaction that would allow him then to be able to publish on the stream. So that was an unintended side effect of the streams that we had to deal with. It took us a bit more time than expected, but we figured it out in the end. So that's the main part about the blockchain. So the second part is about how we generated the island itself. And for that part, I'm going to leave Pierre Armand to talk to you about that.
So what we wanted to have is a nice terrain to explore inside the game because it's an exploration game. So we went with a procedural generation algorithm that allowed us to, with very few inputs, regenerate the same thing again and again. So basically, you have a seed at the beginning of the prototype that you enter, and this seed corresponds to the ID of the island that you are going to generate. And this seed is the beginning of a pseudo-random generation that is going to be used all across the system that generates either the island, either different shaders, different props placement inside the game. So the algorithm is voxel based, and so we voxelize all the 2D map of the terrain. Why we decided to use a 2D map? Because it's easier for checking level design, the level design aspect of different maps. So at the end, we will see that we have different tools that helped us develop the game in order to check different stuff. If the biomes are well placed, for instance, sometimes we had different biomes that we didn't want to be nearby. But what we've done is extract voxel data from this map, and then after this, what we've done is extract a surface that represents the best the terrain, the height map, basically. So I'm gonna quickly show you how the algorithm works. It's not really blockchain related in this case, but it's very interesting to have this information to see how it fits really well with the blockchain idea. So here, the algorithm is working. We have a surface, which is the circle in this case. It's in 2D, of course, for this example. We have a circle that is the height map, basically. It's how we represent the terrain in 2D. And then, after this, we are trying with the red wire, the green wire, sorry, to approximate the surface the best. So the green wire here is the actual mesh that is being generated. So this is one voxel, for instance. Here you can see it. The idea is that you have different vertices that are being activated or not. If one vertex is activated, it's going to generate a small piece of the mesh inside. And if you have different voxels in the same order that are being generated, it will create a surface, like you can see on the second GIF. So why we decided to reconstruct the surface and not use a simple triangle mesh approximation with casual methods? We decided to do this because we wanted to be able to dig inside the terrain to create more interest for the player. So what we've done is at some points we designed a biome with an entry point, and this entry point is the beginning of a cave and tunnels. And we will see later that it's not integrated in the prototype, but we did a further exploration of this tech, and we are able to dig in real time in the terrain. So we can imagine that if the prototype was going further, we would have been able to send different digging information from the player inside the blockchain to add more interest and to hide more stuff, for instance, and to create a quest and stuff like this. So in order to speed the process, we, at the end, as I was telling you, we went with the compute shaders solution. So the idea is that it's not done on the CPU side; it's now done on the GPU. So it's much more faster to generate. So we are able to approximatively generate the full 2 kilometers by 2 kilometers terrain. That is approximately 16 million polygons in 17 seconds. With the colliders, so the player is not falling through the ground, basically. So this is the tech behind. So as you can see, you can dig in real time in the terrain. And we basically subtract densities from the mesh, so from the voxel algorithm. So, and after we are reconstructing the terrain, the actual mesh, the actual surface. So we can imagine that if we send on the blockchain the different densities that have been added or subtracted, players that are reloading the island will grab those information and will be able to find the different holes and addition of densities. So one thing that was quite hard for us was the platform. We went on a very low-end target. So everybody inside Ubisoft will be able to test the game and participate to the expansion of the universe. So we had a lot of stuff to optimize. So it was a lot of time in order to make the player able to see the old terrain from the top of a mountain, for instance. So if you go on top of a mountain, you will see all the biomes, the major trees, and again, it's a very huge map. So we went with different tricks. For instance, in this case, for the LODs, so the level of detail, we decided to render the game twice. One camera is rendering the background with a very bad geometry, and the front camera is rendering very high density polygons, meshes, in order to have more details in front and less detail in the back. But we still have the main shapes in the background, so it gives you interest in the background. So after this, we are going to talk a little bit about the tools. So in order to speed up our development process, we developed some tools using the Unity editor window. So it's a way to create GUI tools really quickly inside Unity. And what we've done is different tools such as the map editor, value editor, in-game editor. I think Robert is going to talk about this.
Yeah, when you have so little time to make a prototype, obviously you have to make some tools, and we try to keep it as simple as possible. So, as we said, we are generating an island, and here, this is the tool that we used to be able to generate the island from a number, because the game, you input a number between 1 and 2 billion, and it's going to output an island. And as you can see here, it's hard to see, but the top part, you have the number, and then the red polygons you see are each biomes that we have in the game. So here we have some canyons, some mountains, some cave. Then you have a bunch of information about each biomes in the middle. And on the far right, you have the island itself with different colors, meaning different things for the game. For example, the red color is going to be about the height. So that's why you see 3 mountains that are red, because red means high, and no red means low. And then you have the other colors that have different meanings that are not necessarily easy to understand just watching the colors. But for us, after a while, you develop some sort of a sixth sense that you say, oh, this is right. But it's been a while, so now it looks like a mess to me too. So you're not alone. And then below that, you have the colors. The white little square you see means white. Okay, you use the regular color, and when it's not white, when it's this brown or some very faint yellow that you can hardly see, this means you want to override the color because this is a desert, or this is a canyon, for example. And the last one, the strange colors you have are color ID, which means that every of the places we were in, using this map as a color information, we could say, oh, that's where we are, and we can use this information to know in which biome we are, because once the terrain is generated, there was no way for us to know where we were. And this was useful for us because we had different moods, ambience for sound or particles or things like this that are related to each environment you are evolving in. So we had to have some way to keep this information very lightly, and this was a very easy way to do so. Here, this is an example of some work we've done that actually didn't get used because we didn't have time to finish it properly. Here it was, you create an island like the one you have on the top, and then you think, oh, the geometry is not perfect. I would like it to be more round or have a shape that's more suitable for what we want to show. And so we had this editor that would say, okay, try and think of every line you see as some sort of a spring, and say, try and find a way for all the springs to stretch in a way that is going to help having a nice geometry. And in 95% of the cases, it worked fine, but in the last 5%, there were some issues that we could not solve, and so in the end, this was a really nice tool that we could not use. So sometimes, you try stuff and it doesn't work. And the final one, this is very simple, but very useful when you are actually playing the game, and you've done it for 50 times now, and every time you start one point of the island, you have to go to the other point of the island, and this island is, we tried to make it big, which means it was long to go from one point to the next. And so with this, we simply teleport. We can check the position of all the important things. Landmarks are marked in white, so we can see the mountains, and we can see some white points on top of the mountains, so it's a good sign. And then if we change place and we die, we can make sure we are spawning back at the border between the previous biome we were in and the new one. So very simple tools, but sometimes just a few things like this, you think like you're wasting 2 afternoons, but in the end you're saving so much time while trying to balance that it's worth the effort. And now it's back to Pierre Armand.
So I'm going to talk a little bit about the pipeline, the art pipeline that we had. We wanted to make the prototype more interesting visually. So what we've done is we designed a little character called Gaspar. Don't ask me why. And it was done inside a tool called Blender, which is a free open source 3D modeling package, an animation and rigging package. And what we've done is for a lot of props, we use techniques such as Vertex Painting in order to change the hue of the color in order to make it more procedurally generated and to have more content inside the game and more variety. So we've done a lot of work on those props. So here you can see different tests that we've done before entering the prototype coding. So on the bottom here, you can see the Vertex Painting process that I was talking about. So basically, it's a gradient of red, and the more saturated red means that you will have, for instance, you will take a material that is considered as a foliage, and the black basically means, oh, it's now it's wood. So we painted all the props like this, and inside the game we have a shader that is actually mapping this color to the actual material information. So this is the only texture we have in the game that is being used inside one big shader, and this shader is relating directly material information, color information, to the location of the item in the terrain. So, for instance, if we have a mountain, it's going to take the terrain row in the bottom, and it's going to take at the top the blue color, and at the ground, yes, it's going to take the brown color. So it's a very easy technique to have a lot of colors, a lot of variety inside the game. And shadows, shadows were very hard for us because it takes a lot of processing. And again, the target that we had was pretty low. So what we've done is in real time, we baked all the shadows, and we used the fake blobs under the characters and the props. And we couldn't have pre-processed this because the islands are procedurally generated, so we had to do this. Oh, I skipped some slide. Can we go back one slide? Oh, yes, sorry. So one other thing that we wanted to add is, again, more variety to make this world more believable. So what we've done is added some grass. Was actually very cost effective because all the grass is being rendered in one draw call, meaning that it's pretty optimized. And we had some animation when the character was walking between the different strands. So it was it was adding a lot of densities, a lot of variety in the world. So the main idea of those shaders, of the two shaders that I'm going to describe. So the grass, basically, when you go when you're walking, it's like a treadmill. Basically, the strand of grass that is at the point is going to be mirrored on the opposite side. So it gives you the impression that you always have grass under your feet. And we have, and we saw that in the tool that Robert showed you a few slides ago, we have a density map for the grass. So that's why in the desert we have a very few strands of grass, and for instance, in the forest we have a lot more. And we use this technique again for creating small particle effects in order to add more, to fake volumetric effects. So when you're flying with your paraglide in the game, for instance, you're jumping on top of a mountain, you will have a lot of wind particle effects that are coming to your face. And again, it's a big cube that is always following the player, and as soon as you have one particle that is going out of the cube, it's being wrapped around, and it gives you the impression of a constant particle effect. And at the beginning of the game, in order to hide the loading, so you have no friction and you are not waiting while doing nothing, we did a cinematic intro in order to introduce the game. And if you are playing as a pioneer, meaning that you're discovering, you're creating an island, you are using your PC to compute an island, you are seeing a small shader that is making the island coming out from the ground. And if you are playing on a client as a client, meaning that you are playing on someone else's island, you are seeing the map as it is. It's loading instantly. And we're quickly talking about sounds. We wanted to add sounds because it sells the prototype even more. So we have different biomes, ambiances inside the game. And again, we're using the maps that Robert shows a few slides ago in order to know where we are as a player, and we are switching sounds and making different ambiances. That's all. Thank you. Yes.
Yeah, maybe. We have time for questions if you want. Just a last thing, I just wanted to remind that we did this prototype 3 people, Pierre Armand, me, and Camille, which is probably hiding somewhere here. I don't see her. And in 5 months. So that's why it's still at an early stage and early tools, but I think it was worth mentioning. So if you have questions tomorrow, just keep that in mind.
And if you want to test the prototype, you can go upstairs.
Maybe we have time for one question. Hi, I think you said you use private blockchains. Can you just explain the advantage of using a private blockchain versus a public blockchain?
It depends on what you want to do when you know exactly what you're doing. When we started, for us, it was less a matter of a public versus private than how easily can we integrate it within a prototype given the time we had and the skills we had when we started on the blockchain. Because again, we are 3D game developers, and we were not blockchain developers. And as such, when we did our first initial research, I tried Hyperledger, for example, and I could not use this easily as being a miner in the game, because we had to embed way too much stuff with it, like a virtual machine and 2 gigs of install. So Multichain was the first tool where I found you have an executable, you can just add it inside the build, you can communicate with it on a JSON RPC call, and you have a C# wrapper that's already provided by some people that's been battle tested. So for us, it was more a matter of efficiency given the time and skills that we had when we started. Because when we started, we had no idea what we were doing because we never had done that before. And we built the skills all along. Maybe today we would do something different. But at the time, this was mostly about time efficiency. And it was not so much about public versus private.